Okay, everyone, welcome to the computer vision portion of this workshop. I'm just going to share my screen. All right. So with computer vision, we're going to be using the OpenCV library. OpenCV is just an open source computer vision library. You can use it with Python, C++. Since we had the Python workshop, we're just going to go ahead and do it with Python. So the only prior knowledge you need for this workshop is Python. I'm using PyCharm right now. The reason for that is that PyCharm makes it really easy to install external libraries. If you aren't using PyCharm, you just go into your command terminal and do pip install, and the library name, it's either going to be CV2 or OpenCV. I'm pretty sure it's CV2, but I don't know off the top of my head, but just try both. But if you're in PyCharm, what you're going to do is go to settings under project and go to Python interpreter. So I have a bunch of libraries already installed. You probably don't have these if you're just starting out, but you're just going to hit the plus sign and you're going to search for whatever library it is you're trying to use. You can download OpenCV just on its own, but there's actually another library you can use called CV Zone. I don't know if you can install this through the command prompt. I haven't tried it, so I mean, maybe it'll work. Maybe just do pip install CV Zone. If it doesn't, then just use CV2, and that should be good enough. And any other libraries you need as we go along, you can just do pip install for those as well. So CV Zone is just a a wrapper library that has a bunch of libraries within it that are very useful when doing computer vision. There's OpenCV is in here somewhere, a bunch of other ones. There's PySerial, NumPy, stuff like that. But anyway, so let's get started. The first thing we want to do is in this, you want to have a folder. Or actually, you don't need to have the folder in the folder, but you need to have everything, all the files that you're using for this this workshop. You want to have them all in the same folder. So I have the Python file that we're working on right now, and in the same folder as that, I have this media folder with a bunch of images in it. So first thing we want to do is just put one of these images on the screen. So we're going to go import CV2, and we're going to define our image. So image equals CV2.imread. Let's say the path, type the path. So it's media image.jpg. Very clever name, I know. And that is just some random image I took off Google Images. Literally just searched up images in Google Images and took the first one. So I don't know what it is really, but then we're going to go CV2 to display this image on the screen. The command is cv2.im show. This first string that we're putting is the name of the window that's going to pop up. So I'm just going to call it output. You'll see what I mean in a moment. And then we give the image that we're trying to output, the image variable. And then we're going to give it a delay. So wait, cv2.wait key is the command. This is going to be in milliseconds. So if you put like 1000, for example, the image is going to show up for 1 second, and then the program is going to stop. But if you put 0, it will actually just display the image forever until you manually stop the program. So there's that. Yeah, the zoom thing is in the way again. There you go. Okay. So if we run that, yeah, you see this image, fountain image, very nice looking. And you see what I meant by the name of the window that's going to open. It's called output. That's what we called it. And so actually, I'll go ahead and just try the 1000 milliseconds. So you'll see it show up for 1 second, and then. So yeah, that's how you get an image onto the screen. Now, we also typically when we're doing computer vision stuff, I didn't do that. Why has this stopped? Typically when we're doing computer vision stuff, we want to be looking through the webcam. most of the time. We can also be like analyzing images or just videos, MP4 files, but webcam is what at least I do most of the time. So we're gonna get a webcam feed into Python. So again, we're just gonna do import CV2. And for a webcam, we're gonna do cap.cv2.video capture. And actually, you can do videos as well. I'll just show how that is. I don't have any videos downloaded here, so I'm not going to run it, but just to show you how to do it. So video and then video.mp4, whatever it is you called the video. Then you're going to do while true success, comma, image equals cap.read. And so what this is, it's going to save the video in an image variable, and the success part is a Boolean. It's going to return true if it did this all successfully. So there's that. Then again, cv2.imshow to put this on the screen. So we're going to give it the name output again. The variable is image. So what we want to do then is with videos, with the images, we didn't have the while loop because an image is just going to be one image just on the screen for however long we want it to be. But a video is a collection of images being displayed one after the other. So if we don't have the loop, it's just going to play the first frame of the video and stop there. So we have the loop to loop through every single frame. So we do if cv2.wait key 1. That's delay 1 millisecond in between frames. And this little bit, so it's not 0. So what this is going to do is if we hit Q, it's going to stop running the program. So actually I was about to run, but I don't have any videos downloaded, so this isn't going to run anything. Okay, I actually need to show you the error message that's going to pop up so you can see. This is the error message that you get when you have when you're referencing something that isn't there. But we want to get a webcam. So what we're going to do is instead of putting a string there, we're just going to put a number. Typically, it'll be 0. This is the ID of your webcam. If you have one webcam, it's typically going to be 0. If you have more than one, then you have to just cycle through the numbers, see which one is whichever one you want. But I only have one webcam right now, so we're going to put 0. And then what we can also do is this command right here, cap.set. We're gonna give it 2 numbers, so we can. I'll just do all of them for a moment, or just 2 of them actually. I'll do 3 and 4. So what 3 refers to the width, and 4 refers to the height. So we can set this to I don't know, some random numbers. I'm picking 300 by 500. Yeah, let's go ahead and run that. Wow, 300 by 500 is very small, actually. Let's go 1000 by, yeah, 500, we'll say. So there you go. You can see the webcam footage, webcam feed. So yeah, that's that. And we can do a lot of analysis of what's going on in the webcam. We can do this with videos as well. We can also do this with images, but again, typically you're going to be doing this most with webcam feed. So yeah, there's that. That is how you get a video or webcam footage. Next, there's some basic commands that OpenCV has that we're going to be using a lot. So we're going to go back to the image. So I'm the same one. So import the image again. And if you want to make this image grayscale, and there are reasons that you'll see later on why we do these kind of things, but you can change how the image looks, so you can make it grayscale, you can make a gray image. So cv2.cvt color. the image you're referencing, and then cv2 dot, and then all this is in caps, so color BGR. The reason it's BGR, typically, and actually when we're looking with the Arduino, we had the RGB LED. Typically when you're doing color picker, you have one of the options is RGB for the colors. OpenCV does it in blue, green, and red rather than red, green, and blue. I'm not completely sure why, but there's just something to be aware of. It's going to come up later a little bit as well. So BGR to gray. So this is going to give us a gray image. So we'll do cv2.im show output and then gray image. Do a delay again. So cv2.wait key 0. So just an infinite delay. So you can see we have the same image, but it's gray as you would expect. So there's that. But there is also more we can do. There are a lot of commands. I'm not going to go through all of them, just a few of them. So another one we can do is a contoured image. So what this is going to do is it's just going to basically just highlight all the contours of the image. And you'll see what I mean in a bit, and I'll explain how it works in a bit as well. So cv2.canny image, and we give these two values just to like how, I guess, how strict, not really trying to phrase it, but how strict it's going to be with the contours. I'll change the values and you'll see what I mean. Actually, I'll put it to be 100 and so if I do contoured image, I spell it. See, oh, contoured, not contoured, contoured. Okay. So you can see it just looks at all of the like lines, I guess, in the image. The way it does this is it's analyzing each pixel and it's seeing that so maybe here for the water, maybe a lot of them are blue, a lot of them are like very close to each other in their color and their BGR value. They're all some shade of blue. But then when it gets here, it goes to a color that's very dramatically different. So it recognizes that there should be a line there. So it draws that line, draws that line. That's how it's working. And I can show you what these values do, kind of. So do 150 and then 200. So 100 again. You can't really see there. Let me pick different values. Yeah. So here you can see very dramatically, it's not picking up many of the contours. It's being very not sure the word. The word is right there on the tip of my tongue, but it's being very strict, I guess, with what it's defining, what it's declaring as a contour. So we're gonna go back to 150, 200. So there is the contoured image. We can also resize the image. So resized image equals cv2.resize. We'll go 1,300. And these are in pixels, by the way, so it's 1,000 pixels by 3,300 pixels. What? Oh, I didn't give a. I don't know what to resize now. Actually, you know, I'll go ahead and make the gray image. I'll resize the gray image. Did I spell that wrong? Yeah, capital I. Okay. So it's going to resize the. What happened? Oh, this should be a point, or not a point, but an ordered pair, I guess. I'm lost, but there you go. So yeah, the gray image has been resized to 1,000 by 300 pixels. So again, there are many more commands you can use, but there's just 3 of them. We'll go over a few more later as we need them. We're not going to go through all of them though. But yes, that is that. Next thing we're going to do is so I have this. I wonder if I can open it right from here. No, not that one. No. This one. Image did not load. Okay, I guess I'll just share this then. So yeah, you see this image right here with all of these cards. So if you've ever used a scanner, like on your phone, just to scan a document or whatever, we're gonna try and do that same sort of thing here. We're gonna try and isolate for this this Jack card and have we're gonna have one window show this entire image and the other window just show the Jack card, and it's gonna be upright. So let's start doing that. So to do this, we're also going to need to import NumPy. So we're going to go NumPy as NP. So image equals cv2.imread media cards JPEG, and we'll set the width and height. Yes, I spelled it correctly. These are going to be the width and height of the second window we're going to open, which is just the card alone. Make it 250 by 300. So the way we're going to do this is we need to have first an array of points that, I guess I'll just show it like this. So if we go into Paint, or if we open that image in Paint, you'll see when we move our cursor around on the image in the bottom left, right over here, you'll see an ordered pair of points of where it is we have our cursor. So this first array, or this first list, is going to be a list of the points of each of the corners of this card. So we're just going to hover our mouse over here and get whatever point it is we're trying to look for. We could also just take a point here, for example, here, here, and here, and it would end up just giving us this little area right here, but that's not what we're looking for. We're just looking for this card. So you get the points where each of the corners are at, and you put them into this array. I already got them, so I'm not gonna go through that again, but the points are, so the first one is, oh, sorry. So, and again, I just got these from looking at the image in Paint. So, okay, so I'm gonna open up the image again. So these points are in the order in which they appear. It's this corner. Wait, I believe if I remember correctly, it was this corner, this corner. Was it this corner? This corner or this corner? It's either this one, this one, this one, this one, or this one, this one, this one, this one. Although it doesn't completely matter in which order you pick them, as long as you're aware of which order you pick them. And I have all these values already taken because this is kind of a pain to go through again to get all these values, but I explained how I did it. So these points, the second list of points is going to be where each of these points corresponds to on our second window that's going to show up. So this point, which is the top left, is going, the top left of the card is going to be 0, 0 on our second window that's going to show up. So that one is going to correspond to 0, 0. The second one is going to correspond to the width of so this width that we defined here, the 250, 0. So that's the top right corner. Then we have the next one is 0, and then the height. So the x is, it's 0 in the x, and then it's going to go 300 down. So actually that tells me then that this third point is the bottom left corner. And then the last one is going to be the width and then the height. So it's going to be going the width of the window to the right and the height of the window down. So that's the bottom left of the window. We'll need to make a matrix of these points. So we're going to do cv2.get perspective transform, and then the first list and the second list. Then we'll go ahead and print that. Then we're gonna create our image. Oh, sorry, I can't divide image again. Output cv2.warp perspective. The original image, the matrix that we just made, and the width and height of the second window. Then we're gonna show this on the screen. So cv2.im show. We'll do first the original image with all the cards next to each other. So we'll call this cards. IM image, and then the next one will be the jack card on its own. Output and infinite delay again, so that they don't leave us too quick. There you go. Oh, sorry. So good. Chat message. Why is my screen so small? Is it? What do you mean it's small? I can tell. Just send it in the Discord. We'll just cut this part of the recording out. Okay, where were we? Okay, yeah. Recording is going on, right? Yes. Yes. Okay. So yeah, let's run the code then. That's not right. Am I gonna have to find the points again? That would be not very fun. But okay, what did I do wrong? Did I do anything wrong? Why is this not working? What does it look like? Okay. You know what? I'll just find the points again. So yeah, we're gonna do what I did not want to do, but we'll find the points again. Maybe I found them wrong. Okay. So the first one is, yeah, it looks like I did it wrong. 223.91. The second one is 431 and 140. 431, 140. Next one is the bottom left. So that is 161, 381. Doesn't have to be exact, exactly on the corner, especially since it's a rounded corner. And it was 371 and 430. That should work. Yeah, there you go. So yeah, I guess I just got the points wrong, but now you've seen how I got the points. And yeah, there it is. There's the jack on its own. It's a little bit wonky, but the points weren't exact. So if I took a little more time getting the points, then it would be fine. But point is that it works. And this is how scanner software works as well. We can actually make a scanner software from something from our webcam using something like this. So we are not going to do that, but just you can do that, just so you know. All right, let's go to the next thing, which is we have another image in here. This one, just a bunch of shapes, and so we want to be able to detect what all these shapes are, so the program should be able to recognize this is a triangle, this is a square, and all that. So first, what we're going to do is we need our contoured image, like we showed earlier with the basic functions. So we'll go contours, comma, hierarchy equals cv2 dot find contours image cv2 dot pr external and cv2 dot. So what this is doing is we have the image. Oh, sorry, this is supposed to be a function. I didn't define the image. This is a function that we're making called get contours. Contours again, contours. We're going to be inputting, giving the image our input. So there you go. It takes the image. With this bit here, this is the retrieval method for all of the extreme outer contours. So in this case, like I explained when we did the contours before for the shapes image, it's very clear where the computer can very easily tell where the edges of the shape are. It's just it goes from black to white, so it's very clear. But with some more I guess some more complicated looking images like the image.jpg, this one, it would need to be a little more thorough with how it's finding the contours, because it's not as obvious as it is there. And this one is whether or not it will approximate the points where the contours are, and we don't want it to, so there's that. Then we're going to go, and this is a list object. This is getting all of the contours of all the objects that it can find. So we're going to go for contour in contours. We're going to find the area of each of these contours. So cv2 dot contour area, another function that we have in OpenCV. So area equals cv2 dot contour area, and we give each, it's going to look for this for each contour within the list. And we'll print the area as well. So print area. We don't want it to, if there's like any imperfections with the image, we don't want it to be picking up little things that just little, I guess, specks of dust maybe or something like that that's on the image and mistake that for a shape. So we're going to say that it will only find the contour if, or it will only draw the contour if the area of the object that it's found the contour for is greater than 500 pixels. So cv2 dot draw contours. Wait a minute, image. Okay, so we create an image, contour image. It's not right. Okay, well, we'll see what error it gives us if it does. Okay, we can just, I'm going to be looking at each contour. And so the -1 means that it's going to be drawing all the contours. This next in this bit here is the BGR value. It's going to be in BGR, not RGB. It's just the color of the contour that's going to be drawing. So this one is 255 on B, then 0, 0 on green and red. So it's going to be blue. And it's going to have a thickness of 2 pixels. Find the perimeter of the contour. So we call CV2.arc length. Arc like contour. And we'll print the perimeter. And then it's going to be making like approximating what the contour is going to look like, especially if you have like dull edges and whatnot. This is useful, so prox. And that bit that 0.02 times the perimeter is the resolution. And then it's tour. So we'll print the number of contours that we see on the image. And typically, or actually not typically, with this specific image, I'll open it again. We have squares, triangles, and circles. So we have three corners, and it would see that and recognize that it's a triangle. 4 corners, it would see as a square. But for a circle, it would see pretty much like as many pixels as there are. I could say infinite number of corners, but there would be a number to it because it will just look at all the pixels. But either way, it's going to be greater than, much greater than any of these. So we say that if it's, we'll say that if it's greater than 4, it's going to be a circle. No, so we're going to have a rectangle drawn around the shape. And that's essentially what this is. It's going to be the rectangle is drawn around the shape, where we're going to have the text above that indicates what it is. So yeah, we're just defining, like I said, what the shape is. What the shape is, given how many corners we see. And we want to be able to differentiate between squares and rectangles. So it's just finding the ratio of the width to the height. If it's a square, it should be 1. It might not be exactly 1. There could be some imperfection with the image. So we give a relative error of 0.05. And then if it isn't, the ratio of width to height is not that, then we can say that it's a rectangle. And again, if the the number of corners is greater than 4, we're going to say it's a circle because 4 is our maximum number of corners. And if you don't know what the maximum number of corners is, you don't have to put 4. You can just put like some absurdly high value, because the circle is just going to have an absurdly high number of corners. So unless you're unsure if you're going to be having a shape with, I don't know, like 1,000 corners, you can just go ahead and put that. And if you have a shape with 1,000 corners, at this point, is it really anything but a circle? So, yeah. And if it doesn't fall into any of those categories, we'll just say it is not a shape at all. And for this case, that's okay, because we know what we're looking for. So we're going to create the rectangle. I have something missing, I think. Okay, we'll see. So we're going to go ahead and start drawing all the rectangles there. And those are going to be, yeah, we'll make them red. We're also going to put text on top of the rectangle to show what the image is. So image and then object type. Chat message. Yeah. Well, you have a question or something like it? What do you mean? Did I mess something up? All right. Okay. So do this is going to be just the position of the top left of the text. And this one is going to be the font. There's some default fonts that we have in OpenCV. All of these. I'm just going to go with the first one. It doesn't matter that much. And the thickness of the text. And then also okay. So yeah, we have that. So let's go. We don't need that. Let's go with image. Just like we did before, we're going to define the path. Oh, yeah. Wait a minute. Okay, well, whatever, we'll see what happens. I create a copy of the image, which we're going to have the contours on. Then we're going to make a, oh, sorry, we're going to make a grayscale image. Yeah, this is one of the situations where we're going to be using the basic functions that we taught earlier. And then we're also going to have a canny image. And we're going to put that on the gray image. Oh, sorry, the speed. Okay. And then we're going to do get contours on the canny image. So get contours and canny image. I actually don't need that, but let's do cv2.im show. I think this will give an error, but we'll see. And 0 delay. So let's see what happens. Yep. Okay, that is not working how I intended. I'm just going to stop the recording while I figure this out. Okay, so I see what's wrong. I forgot to put image contour in a few areas. So if I run it now, you see that the contours show up. Find out where else I did not include it. I think that should be it. Yeah, there you go. Okay, so yeah, I just forgot to put image contours, which we had to find down here, right here. But yeah, everything is working now. Okay, there you go. So yeah, it's able to identify all the shapes. So let's use triangle, circle. It got me wrong. Doesn't seem to have. Yep, everything seems to be good, and it isn't identifying anything that isn't a shape. So that's all good. Yeah. Okay. There's the shape detection bit. Now for the final thing we're going to do is we're going to do a little bit of face detection. That's fun, isn't it? So this is probably one of the most common things you can do with the, I saw the covering. One of the most impressive things you can do with computer vision is be able to recognize a face. Now, recognize what we're going to do is just identify that or identify a face. But you can go even further with that and recognize recognize an actual person. So, for example, you can a lot of cars, well, I don't know what cars it is, but like on cell phones, when you have face detection, what that's doing is it's looking at you. And when you set up your face or your facial recognition, you essentially just go around your face with the camera. You take it's essentially taking a bunch of pictures of your face, and there's a machine learning algorithm. So it recognizes certain features about your face, like the shape, certain imperfections you have on your face, stuff like that. And it's able to through that it's able to recognize who you are. We're not going to be going to that because that's a lot of work, and we simply don't have the time for that. But that's somewhere where you can go further than this. With this, we're just going to be detecting a face. So let's get started with that. So again, we are going to be importing CV2. And there is a folder here called Cascades, which has, I'll scroll over a little bit. You can see all of these computer vision models that have been are pre-built into OpenCV. You can see there's stuff for, you can recognize a smile, a Russian license plate for some reason, full body, left eye, lower body, stuff like that. There's a bunch of stuff. We're going to be using the face one for now. You can use any of these for whatever you want. You can also train your own. The way you do that is, as I explained, how your cell phone recognizes your face is you take a bunch of pictures of whatever it is you're trying to detect. You take a bunch of pictures of stuff that just isn't that. So the computer vision or the model will be able to recognize certain features about what it is that you identify as the object that you want to detect, and it recognizes features about what isn't the object. So, for example, a while ago I was working on a project where the camera would be able to would look at a tomato and it'd be able to detect whether or not the tomato was was ripe, essentially. It'd also be able to detect when it was rotten. So it would look for things like the color, the shape, the sheen. And for the rotten tomato, for example, it would see that it was wrinkly, it kind of had some black spots, stuff like that. And you do that by just gathering a bunch of images of ripe tomatoes, unripe tomatoes, rotten tomatoes, stuff like that, or whatever it is you're trying to detect. And thankfully, you don't have to just go with your cell phone and just take a bunch of pictures of like hundreds of pictures. Typically, you want to go in the hundreds, take hundreds of pictures of whatever it is you're trying to detect. There are ways to take these images very quickly. For example, there's this website called Teachable Machine, which makes it really easy to make these computer vision models. But these ones we have here are all pre-built in OpenCV. So we're going to use the face one. So we'll go face cascade equals CV2 dot cascade classifier. And then we give the path for the cascade. So we've defined our cascade, and then the image is going to be cv2.imread. And I have an image of the one and only J.K. Simmons that we're going to use. There's jksimmons.png. And then we're also going to make the image. We're going to take a gray version of the image as well. So gray image equals CV2. The reason we take the gray image is it just makes it a little bit easier for the computer to recognize the image. If you have a bunch of colors going on, it's much easier for it to recognize the difference between light gray and black or white than it is between like a red and a black, something like that. We're going to apply the cascade to the gray image. There it is. This is the scale factor. These last two numbers I put in, this is the scale factor of the image. So for the dimensions of the window, or sorry, of not of the window, of the face it's detecting. So it's going to again put, like we did the last one, it's going to put a rectangle around the face. So these are dimensions of the rectangle. So cv2 dot rectangle image x and y, x plus the width, so that is the top left, and then y plus the height. Oh, actually, I don't know if I mentioned this before, but I should. So this is the image we're going to be using, J.K. Simmons, as I said, wonderful actor, with OpenCV, and actually with a lot of Python libraries that have some sort of graphical interface, like Pygame, stuff like that. The convention for the points is not the same as the standard like Cartesian system you learn in math. 0, 0 is actually up here, and then the width of the image comma 0 would be over here. The 0 comma the height of the image will be here, and this will be width comma height. But the point is that 0, 0 starts in the top left rather than the bottom left, like you would expect in a normal Cartesian system. Then this is going to be the color of the rectangle. It's going to be a shade of green. And the width of the rectangle. So we're going to also put text above it to recognize, to just say that this is a face. You know, it's just going to say face. So image, and the text is going to be a face again. So x minus 5 is going to be on the top left of the rectangle. So y minus 10, and then cv2 dot font. Let's go with the first font. And then we're just going to show the image. So I'm show. since we don't want the gray image to show up, we're doing all these operations on the gray image, but we can just put the rectangle on the original image given the position of the gray image, because they're the same image, just different colors. So that works fine. That infinite delay. So let's go ahead and try that. Something went wrong. What is the problem? Where does it say the error is? Line 7. So it's here. Probably misspelled something. CASCADE. That's good. Why isn't it working? Let's stop the recording again. I'll try this. Okay, so the error was I just misspelled this. It's called Cascades and not Cascade. I thought the error was over here, but there you go. So it should work now. Yep, there you go. This should be. There you go. So it's able to detect the face. And we have the face written in green, or we have face written in green above on the top left of the rectangle. So yeah, there you go. And you can also implement this with the webcam footage as well, which is kind of what you want to go for rather than just still images. And you'll be able to recognize your face live on the webcam feed. Not going to go into that for this lesson, but again, this is to give you a good basic understanding of computer vision. You understand kind of the basic functions that you have, what you can do, sort of. But again, there's a whole lot more that you can do with OpenCV, with computer vision. It's a very powerful tool to have, and I highly recommend you. I mean, the internet's a great resource to learn this. I highly recommend it if you want to continue learning. There is one YouTube channel, Murtaza's Workshop, just so you can spell it out, or so you can know how to spell it. This one right here, Murtaza's Workshop. Really good place to learn computer vision, robotics, machine learning, stuff like that. It's a really good channel. Well, mostly for computer vision, but yeah, it's pretty good. Anyway, that is it for this workshop. The recording should be up soon, next week, hopefully. And the Discord should also be ready very soon as well. And you can ask questions that you have in the, we'll have a specific text channel for this workshop, and every other workshop will have a specific text channel. You can ask any questions that you have in the channel, and any of the other participants or any of the organizers can help you out. So yeah, there's that. The event, the hackathon is in 2 weeks, so good luck on your submissions. All right, yeah, that's it.